My name is Bjorn. I'm the CEO from Duca Systems in Switzerland and Germany. And today I would like to tell you something about the importance of digital controlled production. When I started in the construction industry almost 20 years ago, I've got a really good insight into the production of the side products. At this time, I was working for a supplier with its own production and was responsible for the organization and the quality. At this time, we produced nearly everything for structural construction, like punching shear reinforcement as well as shear studs or facade anchor and so on. But one of these products catch me really hard. It was especially the rebar splicing system. At this time, we worked in more than, it was around 3 shifts the most time, with a couple of machines and produced really huge quantities of these rebar splicing system. Initially, it was with a tapered thread, so it was a thread which was cut onto the rebar, and later then we changed to a threaded coupler which were crimped onto the rebar, so similar to the system which we have today. I will tell you why these rebar splicing system, or rather the way it was produced, catch me so hard. But first, I would let you know why something interesting about the production of rebar itself. So when reinforcement steel is produced in the mills, they have strict control requirements given by the individual standards. These requirements are really important because, as you know, rebar and concrete are the main products which are responsible for the stability of a building. So, for example, according to the standard EN 10080 or British standard 4449, which are only 2 of these standards to regulate the production of rebar. There's written that during the production of rebar, every 30 tons, a tensile test must be carried out. For those who didn't know what a tensile test is, a tensile test is a laboratory takes a rebar, clamp it on both sides, so at the bottom and at the top, and pull it till it breaks. Then they make the evaluation of the results and document it. That has to be done every 30 tons. 30 tons of rebar is a lot of stuff, but definitely not for a rebar mill. An example, one of the big players on the market of rebar mills has a capacity to produce 900,000 tons of rebar every year. If we now take 250 working days, we have an average of 3,600 tons per day, which is possible. So remember, every 30 tons, a tensile test must be carried out. With 3,600 tons each day, we have to make 120 tensile tests every day. So 120 times, a laboratory has to take a bar out of an ongoing production, take it to the laboratory, clamp it, carry out the test, document it, and so on. 120 times every day. And is that too much? From my point of view, a little bit, but we have to be honest. We are talking about absolute elementary components for the stability of a building. So quality checks during the production needs to be done. So now let's take a look to the mechanical connection of this rebar, so the rebar splicing system. Of course, there are also regulations for the production of rebar splice, which given by standards and approvals and so on. But in this area, there are internal requirements which are more concentrated on the coupler production itself, and external requirements which are carried out by third-party inspectors. And these are usually annually. and only at certain productions. So it is possible that a production can deliver goods to the market within a period from around 3 years without being really sure that they produce the expected quality. In theory, there are internal controls, so random checks with measurements and thread gauges and so on, but I also know that these random checks often will be forgotten. So similar to the memory gaps of the German president. A good example of production fails was given by Cross UK. Cross UK is a provider of safety information for the construction industry. And in 2019, they wrote an article which mostly reflected my experiences. In this case, delivery of rebar splice, it was with a taper thread, was inspected at site. During the inspection, it was already visually apparent that the threads were completely different. The length of the thread, as well as the depth and the pitches, varied within the individual diameters. The manufacturer of the rebar splice had the instruction in its quality specifications to check every 10th thread with a gauge. After the damage was reported, the coupler manufacturer inspected the machines which were used to cut the thread and confirmed that the machines were working properly. So accordingly, the cause of the defective threads was due to errors made by the machine operator. In this case, unfortunately, is not an isolated case. Humans make mistakes. It was always like this, and it will be always like this. And for sure, it will getting worse in this area of machine operators or employees at site or something like that. I'm sure it will not getting better in the future. But rebar splicing is a mechanical connection of rebar for reinforcement steel. So it must transfer the performance from one bar to another bar. That's the idea of a rebar splice, that the performance must be transferred, and it must be transferred like it's written in the approval. We therefore need a high level of process reliability for each produced connection. So we need machines which control the manufacturing process, and at least the human. We must be aware that today in the 21st century, after already a few decades of rebar splice on the market, are still some systems at the market which has an historical machine technology. And what are we doing? On one side, we rely on approvals, and on the other side, we rely on random checks from the operator, which hopefully will be done. In my opinion, this is extremely dangerous, and something needs to change. The quality of rebar splice could no longer be the responsibility of the machine operator alone. This is how the idea came about to control the production of rebar splice by the machine. So it's regardless whether the operator is concentrated on the job or not. We developed a machine where during the production, the machine monitors the entire manufacturing process. If one result is not within the target due to, for example, the operator chooses the false coupler, the false rebar, or asymmetries in the rebar, the machine reports this fall immediately to the operator and stop the production. So the machine stopped the production for the operator, and the operator can't go ahead before he didn't solve the problem. He has to solve the problem before he can go ahead. Otherwise, he will get this error again and again. So The machines therefore provides a perfect basis for consistent rebar connections based on the approval. We also decided to have a documentation of every produced rebar splice created by the machine. This means that we can prove the results for each bar from the production. In this documentation, you have information about for when was it produced, for which project it was produced, which coupler included the batch number, was crimped onto which rebar, and it is also possible to trace for each crimped coupler which pressure was used or which pressure was achieved, which crimping diameter was achieved, and whether the crimping diameter was within the required tolerance. Everything is inside this documentation. This means you have a very clear quality documentation of your construction projects, which is available through this new level of production quality and documentation of rebar splice. Is that brilliant? I don't think so. Because we are in the 21st century, it has to be like this, in my opinion. It has to be like this. The technique is there. We need solutions like this because it's an elementary component. We had carried out an international research to look for a comparable system, but found nothing where the production of rebar splice was that fast, monitored, and documented in the same extent as with our ZENTOR rebar splicing system. For the Duca Systems Group, the safety of construction products with sustainable quality is really important and has become more or less a corporate slogan. We should place much more focus on digitally controlled production processes during the manufacturing of relevant construction products to be able to guarantee the safe buildings in the long term. So from now, please use digital controlled products of rebar splice. Thank you very much.